Welcome Year 11. In today's lesson we're just going to review over abstraction and decomposition and look at the homework answers. So what we were supposed to have grasped this week was the concept of abstraction when we're programming. This idea that we're going to remove unnecessary details from within our program, especially through the use of functions. If I scan very quickly forward to the video, if you watch through the video, an excellent example here is the use of icons, that they're removing unnecessary detail from those graphics, but I understand that that key is probably for a lock, that is a computer monitor, that means music, and that means find. Alright, I don't need to know all the detail, I just need to know what it does. And the second concept that we came across was decomposition, breaking problems down into the smaller parts, making it easier to solve. And again, we will look at that in the homework, but it's important that you understand, or that you have a definition for each of these. Abstraction, removing unnecessary detail; decomposition, breaking problems down into smaller parts. A great example there was the racing game. But when you're designing a computer game, you're going to consider all the different elements, the graphics, the gameplay, the artificial intelligence, engines, etc, etc. And you looked at this in junior school when you created your game yourself. You looked at the breaking down, solving the character, solving the problems of the walls, solving the enemies, solving the bullets, etc, etc. And that takes us to our homework. Can I just remind you of the importance of handing in our homework in time while we're in lockdown? I can accept work after it, but I can't give you full marks once we go through the answers. So I'll pick on Harry's, he's top of the pile. We look at Harry's answers and just go through it. The first question, generally, Harry's answer excellent, but it was generally answered poorly. Too many of you didn't read the question properly. The subroutine letter, it's already been provided for you, you didn't need to program it. Write an algorithm that uses this subroutine to convert any name entered to a list of characters, and you're even given a hint. It uses iteration, and you call the function in each iteration. So if I look at that, and again you just needed pseudocode, but if I look at this programmatically, let me get a script, a blank script. So we've got a function letter, I don't need to program that. What I do need is some type of an array to store the characters. I then need someone to enter in their name, and that's going to be my input statement. Enter your name. Now we go back to our homework. It says some type of iteration or looping structure, and in each time go through it and call the function. So I'm going to say for L in name, which is a variable where their name will be stored, array characters dot append. I'm appending into this, and this is where I'm going to call the function, and the function was called letter. And what am I passing into that function? Sorry, that's square bracket. I'm passing in L, and then the final thing I would do is print the array characters. Now this will not work at the moment because I don't have the function, but that's all you needed to do. It's abstraction. We don't need to know how letter works, we just know that it works. And that takes us to Harry answers, and you can say something like this, that we've got a name, we've got an array to store it, and we iterate through it, appending in the character that's been generated by that function. The next two questions, too many of us made the mistake, we didn't refer to the example. We know that abstractions remove an unnecessary detail. In this example, it's letter. All the detail from that has been hidden from us. We don't need to know how it works, we just know that it works. And then decomposition, breaking it down into smaller parts, solving the different parts of decomposition, breaking it down into smaller parts. That is using the letter function to solve one part, getting a number for each individual character, and then the second part Harry has solved is doing it for an entire name. So if I look at just another example, who's actually coded it, I think, where did I see? Oh, Maria. I'm going to steal Maria's code because Maria's actually coded a function that will a letter function, and I take that into my script and I paste it, letter, just check that it's spelled, and I'm calling it now. And when I run my script down here, enter my name, and there we've appended in here. And when we talk about abstraction, I do not need to understand Maria's code. I just know what it does. It takes in a character and it returns the offset in the alphabet. It works. Decomposition, there's one part of the problem solved. Second part of the problem, I've written that. It's allowing two programmers to work together. Maria solves that problem, I solve that problem. Decomposition. Just to look at Maria's code, because it is such an excellent example and trying to explain it. Maria's taking in an array and she's using something called the ORD function, and in Python the ORD function returns the ASCII value. Every character in the keyboard is encoded 0 to 127, and that's going to give us a value, and Maria's passing in whatever letter, but she's forcing it to be upper, and then she's subtracting 64. I would probably simplify that. I'm just going to simplify this, and I'm going to cut that, and I'm going to return that minus the 64. And again, we're just looking at different levels of abstraction. We don't care as long as it works. What does that do? How does it do it? Doesn't matter, it works. So that's the idea. Decomposition, two small parts of the problems. Abstraction, remove the unnecessary detail. So folks, it's, if you go through, make sure you go through your answers, you grasp those basic concepts, and that you are available for next Monday's lesson. We'll be meeting again at what time is our Monday lesson? Let me check our diary. That is 11:50 again on Monday, and we'll be looking at pseudocode. We'll be looking at valid flowcharts and pseudocode and how we actually write algorithms. Catch up your work, folks, and good luck. Enjoy your weekend.